a copy of the stats project that I'm working through just to show you what I should see. So the first part is to do these experiments where we roll the die many times and we collect some data. Okay, and one suggestion I had for you was going to this random.org site and using their dice rollers. So I'm rolling like 54 dice here, and I'm just sort of, like here I rolled a 6 and then a 1. So that first thing we would record there is a 6-1. Then I have a 3-3-6-6-1, right? So I record that, right? And so I've already done that for a lot of these because it's kind of boring to watch me do it. But you can see it here, 6-1, 3-3-6-6-1. The next one's 3-5-5-2-5, 3-5-4-1. So that is this one, 3-5-5-2-5, 3-5-4-1. And then I'll write these couple here for you. So 2-6-2-5-1. Okay, so here 2-6-2-5-1. Okay, and then our last one here is let's see, where did I get this one from? I gotta remember what it was. 2-6-2-5-1, and then here a long one. Okay, 2-6-6-3-4. 2-6-6-3-4. 2-2-5-3-5-1. 2-2-5-3-5-1. Okay, so here is our 20 rolls. And then what we actually are interested in is the number of rolls till the first one. So now I want to count all these things, right? So I'll just do equals count. Okay, so by the way, this is one place where you should let Excel do the work for you. Right, so I can do that. And then it'll actually fill out all the rest of these for me. So I can just check and it'll fill all those out. I didn't really want the, let's see, it's trying to be too smart. It's adding all these borders and things that I didn't really want there. Okay, yeah. Not sure why I did that. Sorry, let me just fix this back up. Okay. Not too important, but just want to keep it looking like that. Okay, so it did all the counting for me, right? So there were 3 till the first one here, 2 till the first one here, 5 till the first one here, right? 1, 2, 3, 4, 5, right, etc. So it does all that for me. Okay, and then the next thing you were supposed to do is just take the and by the way, if you think about this in terms of our interpretation, we have this device that may fail 1 in 6 chance every year, right? That's the idea. Okay, so 1 in 6 chance, it's like rolling a die, right? So here it didn't fail the first year, didn't fail the second year, failed the third year, right? Here it didn't fail the first year, failed the second year, right? Here it failed on the 5th year, right, etc. That's the interpretation we have here. Okay, so for mean here, I actually give you the formula, so I just use this formula, equals average. Oops. Let's see. Again, it's trying to be too smart. Let's try that again. Equals average. I didn't want it to fill that out for me. And then I want these. Okay. Okay, and then equals stdev, standard deviation. And then I'm going to take all these guys. All right. Okay, there we go. Okay, so our mean here, the average is 7.2, the standard deviation is 5.156. And let me just reduce the decimal points there a little bit. Let's have 2 decimal points for each of these, why not? Okay, so so here we have our interpretation, okay, and so the interpretation here, if I can get in there and type, is going to be, something like we expect the device to fail at 7.2, basically plus or minus 5.16 years. Right, and that's really all I want there, right? So I just want the English interpretation of this experiment we just did, right? And so, we did this little experiment, we did this thing 20 times. If you have device that might fail, 1 in 6 chance every year. Say your research department has found this out and you were doing some statistics for them, and you're doing it this way where you're just simulating it. You may want to simulate it more than 20 times, right? So you get a little bit better data here. But anyway, that's what the next part's for. The next part's to sort of calculate the theoretical mean and standard deviations for these things. Okay, so that's what we'll do next. Okay, so we come over here to part 2. In part 2, same thing, right? The x is the number of rolls until the 1 is first rolled. Okay, so I'm going to start with the explanation, then fill out the formula, right? So I'm interested in what's the chance that we get a 1 on the first roll, right? So that would be just p of a, roll of 1. I'm just going to say p of 1 for p of roll of 1, right? And so the chance of rolling a 1 on a 6-sided die is 1 in 6, right? So that'll be it, right? So this would be the probability right there, 1 in 6. Let me see, let me justify those, okay, just to keep that over by that equal sign. Okay, now here, right, if I'm going to roll a 1 first on the second turn, right, then I have p of basically not a 1, then 1, right? I mean, so first I'm going to roll a not 1, then I'm going to roll a 1, right? And instead of writing then there, let me just write and, because that sort of matches our formalism a little bit better. And I'm going to make and uppercase to just, I don't know, make it clear that's a logical thing, right? And then you have to think a little bit, and what I get on the first roll and what I get on the second roll will not depend on each other, right? If I don't get a 1 on the first roll, that doesn't affect what happens on the second roll. And certainly what I get on the second roll doesn't affect what happens on the first roll, right? So these are independent. And so when I have an and in here and I have independent things, then I can say this is just p of not 1 times p of 1, right? And so that is, how many ways are there to not get a 1? Well, there's 5 and 6 ways to not get a 1, and 1 and 6 ways to get a 1, right? And so that's the formula I want here. So I want 5 over 6 times 1 over 6. Okay, and then p of 3, same thing, right? Except it's p of not 1 and not 1 and 1, right? So this is equal to, I'm just going to cut and paste some. Copy this, paste it, but now I need another p of not 1 times, okay, p of not 1, so I now have 2 of these, so 5 over 6 times that, okay, and so this ends up being 5 over 6 squared times 1 over 6. And there's our formula there, right? So 5 over 6 raised to the 2 times 1 over 6 will be our formula for that. Okay, and I think maybe we see the pattern. Basically, I just have a 5 over 6 to some power, and that power is 1 less than the first place I roll a 1, right? So here the power is 0. 5 over 6 to the 0 is just 1. And then, for x equals 3, it's 5 over 6 to the 2, right? So this is 1 less than the number that's there. And so our general formula here will be 5 over 6 raised to the n minus 1 times 1 over 6. Okay. And this is the sort of thing I need to see. I need to see this, the formula, not, like here it doesn't help to see 5 over 36, and right here it doesn't help to see 25 over whatever 6 cubed is, right? You want to see this pattern, right? So you need to see this pattern here. That's what we're looking for, okay? And so here you can just, for the answer here, we can just say, see pattern. And that's not sort of mathematically rigorous, but that's fine for this class. Okay, so now that we know how to compute the probability, we can compute these things, right? So here, I know that I want this to be 5 over 6 raised to the well, what? It's this I, this is the same as the n, right? Minus 1, times 1 over 6, right? And so that's the formula I need there. And then let's shrink this. Let's just make like 4 decimal places is enough, I think. Okay, and then now I just want to copy this across and let's just see what happens when I do this. All right, it fills out, and then when I look here, right, and I see that the exponent has done what I wanted to do. It looks at, in fact, if I click here, I think we can see, right, it looks at this one, not this one, right? And then if I go to the next one, so this spreadsheet tries to be smart, right? And so when I go look at it, right, it switches and looks at this one, right, which is what we want. Okay, so this is, whoops, let's not have it do anything. Okay, so there, right, so these are probabilities. Okay, and then now the rest is just this, right? So now I want to multiply I by that probability. So this is equal to, I times that probability. Okay, and again, let's get this down to 4 decimal places. Oops, 4. Okay, and then we can just carry this one across. Okay, and same thing here, right? So equals to this squared times this probability. Okay, and again, we'll get it down to 4 decimal places. Okay, get it across there. All right, and there we go. Okay, and then the expected value of x for the approximation, right? I mean, we'd have to go to infinity to get it exactly right. So we're just approximating with these first 20 terms. But we're going to sum up this, right? The expected value is the sum of I times p of x equals I, right? So here we're going to have equals sum of this. Okay, and I don't want it to fill out for me because it's going to mess it up here. I guess it would have gotten the first one right. So here I want equals sum of, I think this is right. Yeah, so we'll just take what it's giving me here. So that's right there. Okay. And we'll leave those 4 decimal places. Okay. Variance is equal to this thing, ex squared, so it's just this minus this squared, right? So these formulas are, of course, all in the instruction sheet or the project write-up. And then the standard deviation is just the square root of, whoops, SQRT of this, right? Okay, so this is what we get for our answers, and then we want the same sort of description. I don't know why this is putting this silly bar here. That's a weird thing it's doing. So the interpretation now is going to be the device is expected, oops, to fail at 5.32 years, give or take, or take 4 point, let's call it 4.39 years. Okay. You can do a little calculation on the side. If we do, I mean, sometimes people do this, like put a low and a high, right? And so here I will have equals to, the low will be the expected value minus the standard deviation, right? And the high will be equal to the expected value plus the standard deviation. Okay, and so we're saying the device is expected to fail somewhere between basically a year and 10 years, right? So it's a very big window, right? And just to go a little bit further, since we went out 1 standard deviation, and if we make some assumptions on how the numbers are distributed here, we might even be able to say that we expect with about a 68% probability that the device will fail somewhere inside this interval. If we wanted to increase the probability to 95%, we would need to go out 2 standard deviations, right? And so that would be an even bigger window here, right? Anyway, that's the basic idea. I mean, that was not required of you. You were just sort of required to write something like this, and then do these calculations, right? And I mean, I do want to see. I would really like to see formulas used here for all these calculations. That makes it much easier for me to see what you're doing. But at the very least, you have to have these explanations up here for what you're doing in these calculations. Um, and of course, it's nice to see formulas used here to see what you're getting instead of just having numbers here. Because if there's numbers here, there's nothing for me to look at. There's no actual math for me to see. Here, I can see that you're sort of doing the math right. You're asking the the computer to do the math for you in some sense, but I wouldn't expect you to sum these things up and take square roots by yourself anyway. You'd use a calculator for that anyway. Okay, that's what I'm going to do in this video. I'm not going to cover part 3 here, just part 1s and 2s, since part 3 was optional.